Hi, my name is Bahadur Akhmedov. In this video lecture, we are going to discuss about the values of trigonometric functions for some important angles. We first of all need to define what is a trigonometric ratio. In order to do this, we need to define the triangle with the right angle. So essentially, the right angle is the angle which is equivalent to the 90 degrees. So please note that this angle is going to be the largest angle in the triangle, and the side which is opposite to the 90 degrees or the largest angle is going to be the largest side of the triangle. So we call the largest side of the triangle as the hypotenuse. So now if I would like to define the sine and the cosine of this angle alpha, what I have to do is I need to find the ratio of the y to the r or x to the r. So essentially, we define the sine of alpha as the ratio of the opposite side to the hypotenuse, and the cosine of this angle is going to be the ratio of the adjacent side to the hypotenuse. So let's say you've got a triangle with the sides. Let's say this side is going to be equal to the 4, and this side is going to be equal to the 4, for example. Then the length of this side, the hypotenuse, can be found using the so-called Pythagoras theorem. So the h in the square is going to be equal to the 4 in the square plus 4 in the square, which is 32, right? Or essentially 2 times to the 16. And if you would like to find the h, it's going to be equal to the 4 times to the square root of 2. So this h is going to be equal to the 4 times square root of 2. So now, if you would like to define the sine or the cosine of this angle alpha, what you have to do is you need to divide the opposite side to the hypotenuse or the adjacent side to the hypotenuse. So essentially, the sine of alpha is going to be equal to this side 4 divided to the hypotenuse. So to this one, it's going to be 4 divided to the square root of 2. And the cosine of the angle of the same angle is going to be the ratio of this side 4 divided to the hypotenuse. So this is how we can find the values of the sine and cosine on the triangle. So what would be interesting for me is to figure out the values of the sine and cosine for the following important angles. So I would like to find this for the 0 degrees, for the 30 degrees, for the 45 degrees, for the 60 degrees, or for the 90 degrees. And in order to define the values of the trigonometric functions of these important angles, I'm going to use the triangles and the unit circles. So a circle whose radius is equal to the 1 is called the unit circle. So now what I want is I would like to just rotate this terminal line up to some angle alpha, okay? And I would like to figure out the values of the sine and cosine for this angle if I'm given the coordinates of the terminal point. So essentially, in order to do this, we need to just make a triangle. And for this triangle, the height of the triangle is going to be equal to the y, so essentially the y coordinate of this point, and the width of this triangle is going to be equal to the x coordinate of this point. And if you remember, we define the sine and the cosine on this triangle, right, as a ratio of the sides into the hypotenuses. So in this case, if I would like to find the sine of this angle alpha is going to be equal to the y divided to the hypotenuses, in this case, it's going to be equal to the 1, since the radius of a circle, of a unit circle, is equal to the 1, and which is going to be simply y. And the cosine of the angle is going to be equal to the x divided to the 1, which is simply going to be equal to the x. So essentially, x and y coordinates of the points are going to tell me the values of the sine and the cosine for this angle. So essentially, if you would like to just rotate this terminal line up to some angle alpha, then by finding the terminal point, you are going to figure out the values of the sine and cosine. So let's do this procedure in order to find the angle, the values of the trigonometric functions for this standard or the important angles. So if you would just like to start with a terminal line, if you're not going to rotate this at all, so essentially the alpha is equal to the 0 degrees, right? Then this terminal point is going to obviously have the coordinates to be equal to the 1 and 0. So I'm going to just make the correspondence that cosine of the angle should be always corresponded to the x-coordinate of the point, and the sine of the angle is going to be the y-coordinate of the point on this unit circle. So essentially, the cosine of the 0 degrees is going to be equal to the 1, right? So since this point here has the x-coordinate to be equal to the 1, and the sine of this 0 degrees is going to be equal to the 0, since the y-coordinate of this point is going to be equal to the 0. So now let's rotate the terminal line up to 30 degrees. And I would like to figure out the values of the sine and cosine. So if I would like to find the values of the sine and cosine at the 30 degrees, I need to just find the lengths of this side of the triangle and the length of this side of the triangle if the radius of the triangle is given to be equal to the 1. So let's look to this triangle in more details. And again, so this angle is equal to the 30 degrees. So, and the radius is equal to the 1. So I need to find the y and x sides, right? So in order to do this, I would like to just split this triangle into the pieces, into the exactly 2 pieces with the certain angles. So essentially, this angle is going to be equal to the 30 degrees. So since originally this angle used to be 90 degrees, then this blue angle here is going to be equal to the 60 degrees. So at the same time, if you remember, our original triangle was like this, right? So it was the 30 degrees here and 90 degrees here. And I can find this angle here as well, right? By subtracting 30 and 90 from 180. So 180 degrees minus 30 degrees minus 90 degrees is going to be equal to the 60 degrees, which is the value of this angle. So essentially, this angle is going to be equal to the 60 degrees. Then, since the sum of the angles for any triangle is equal to the 180 degrees, then this angle is going to be equal now to the also 60 degrees. So you see, so I've got here isosceles triangle. So essentially, all the sides of the triangle of this triangle are equal. And at the same time, so here I've got 30 and 30, and this angle is going to be equal to the 120 degrees. So what is important for me is that the lengths of the triangles with the equal angles are going to be the same. So for example, the length of this side is going to be the same as the length of this side. So since the corresponding angles are the same, right? At the same time, you see, so the opposite of this 30 degree is going to be this side, right? And opposite of this 30 is going to be this side, and they are the same as well, okay? So again, so this side and the 3 sides of this triangle are the same, and the 2 sides of the triangle are the same, right? So which will lead to the conclusion that actually the purple side is the same as the green side, okay? So essentially, if I know that the hypotenuse, the longest side, the hypotenuse of this triangle is equal to the 1, since the radius of a circle is equal to the 1, then if I'm going to split this exactly to the 2, since the green side is equal to the purple side, then the length of this side is going to be equal to the 1 over 2. The length of this side is going to be equal to the 1 over 2. So since they are equal. And at the same time, since this side is equal to the 1 over 2, then this side is going to be equal to the 1 over 2 as well. So the y is going to be equal to the 1 over 2. Okay, so when the angle is equal to the 30 degrees, then the y-coordinate of the point is going to be equal to the 1 over 2. So essentially, how I can find the x-coordinate here is to use the Pythagoras theorem again, right? So this y-coordinate here is equal to the 1 over 2. What is going to be the x, right? So again, the Pythagoras theorem tells you that x in the square plus y in the square, which is 1 over 4, right, is equal to the radius in the square, which is equal to the 1. From here, I can find that the x squared is equal to the 1 minus 1 over 4. If I give the common denominator and subtract these two numbers, it's going to be 3 over 4. Then the x in this case is going to be plus square root of 3 over 2, since for this point, the x is a positive number. So if you remember the coordinates of this point, so essentially I found the coordinates of this point, right? So here the x is going to be equal to the square root of 3 over 2. And the coordinates of the points are going to tell me the values of the sine and cosine. So essentially, the x coordinate is going to tell me the value of the cosine of 30 degrees, which is going to be square root of 3 over 2. And the y coordinate of the point is going to tell me the value of the sine of this angle. So this is going to be equal to the 1 over 2. So I would like to continue rotating this terminal line up to some angles and figuring out the coordinates of the points and consequently the values of the trigonometric functions. So now if I rotate the terminal line up to 45 degrees, then I will get this triangle. And again, so I need to figure out the coordinates of this point, of this red point. So now let's look to this triangle in more details. And again, the radius of this triangle is equal to the 1, or the hypotenuse of this triangle is equal to the 1. So since this is 45 degrees, so this is the 90 degrees, the length or the value of this angle is going to be equal to the 180 degrees minus 90 degrees minus 45 degrees, which is going to be equal to the 45 degrees. So please note that I'm subtracting these two angles from the 180 degrees since the sum of all of the angles of the triangle should be equal to the 180 degrees. So this angle is going to be equal to the 45 degrees as well. So you see, so the sides which are opposite to the equal angles are going to have the equal lengths as well. So this is essentially is going to be x, and this is also x. So these two sides are equal. Then by using the Pythagoras theorem, I can figure out the lengths. Okay, so the Pythagoras theorem tells me that x in the square plus x in the square, right? The square of this side plus the square of this side is going to be equal to the square of this side, which is going to be equal to 1. So on the left, what I have here is 2x squared is equal to the 1. From here, I can find that x squared is equal to the 1 over 2. So that's why x is going to be equal to the 1 over square root of 2. So essentially, the x and y side of this triangle are the same. So that is why for this point, x and y coordinates are going to be the same, and they are already equal to the 1 over square root of 2. So the x is equal to the 1 over square root of 2, and the y is also equal to the 1 over square root of 2 for this angle, which is 45 degrees, which will lead to the conclusion that the sine of the 45 degrees is equal to the 1 divided to the square root of 2. And at the same time, that the cosine of the 45 degrees is also equal to the 1 over square root of 2. So let's rotate the terminal line up to 60 degrees. So if I would just rotate this up to 60 degrees, then if I would be interested to figure out the values of the coordinates of this point. And again, I'm going to do the same technique as we used to figure out the coordinates of the points at the 30 degrees. So I'm going to look to this triangle in more details, and I'm going to split this triangle into the two pieces, essentially two triangles. So this angle is going to be here. I'm going to split this exactly like this angle is going to be equal to the 60 degrees. So this angle then essentially is going to be equal to the 30 degrees, right? So this angle is also 30 degrees. This angle is going to be 120 degrees. And this angle is going to be equal to the 60 degrees. And again, so I can see that this triangle is going to be the isosceles triangle, which is basically all the sides of this triangle are the same. At the same time, for this triangle, the sides are going to be the same. So the two sides are going to be the same. So which will lead to the conclusion that the blue side is equal to the purple side, right? So essentially the hypotenuse of this triangle is equal to the 1, which should be split into the equal parts. So essentially this green part is going to be equal to the 1 over 2, and the purple part is going to be equal to the 1 over 2, right? So that is why this green part here is going to be equal to the 1 over 2. So essentially the x is going to be equal to the 1 over 2 in this case. Okay, so the x coordinate of this point is 1 over 2. So I can find the y-coordinate of this point by using the hypothesis theorem. So Pythagoras theorem, sorry. So which basically tells me that, hey, x in the square, x side in the square plus y side in the square, so this is the y side in the square, is equal to the radius or the hypotenuse in the square. So I'm just going to put the values to here. So x in the square is 1 over 4, right? Because x is equal to the 1 over 2, plus y in the square because I don't have the y square yet. The radius in the square is going to be equal to simply 1. So if I find the y square from here, I need to subtract 1 over 4 from 1, which is going to be equal to the 3 over 4. Then the y is going to be equal to the square root of 3 over 2. Okay, so this point is going to have the coordinates 1 over 2 and square root of 3 over 2. And essentially, I can find the values of the trigonometric functions um, by finding the coordinates of that point. So now the last point which is left is obtained by rotating the determinant line onto the 90 degrees. Then the x coordinate of this point is equal to the 0, right? So that's why the cosine of the 90 degrees is going to be equal to the 0. At the same time, the y-coordinate of this point is equal to the 1, so it means that the sine of 90 degrees is going to be equal to the 1. So essentially, this angle is equivalent to the 90 degrees. So that's why the coordinates of this point are going to be simply the values of the sine of the 90 degrees and the cosine of the 90 degrees. So now what I would be interested in is to write down all of the values of the sine and cosine for all of these points. And I can do this by going through the x or y coordinates of the points. So essentially, when the sine is, so when the angle is equal to the, so I'm going to write down the values for the angle. So at the 0, right? At the 30 degrees, so this is the 30 degrees. At the 45 degrees, sorry. So this is going to be 45 degrees. At the 60 degrees, so this is going to be the 60 degrees. And at the 90 degrees. So this is going to be the 90 degrees. Okay? So at the 0, the sine, which is going to be the y value of this point, is going to be equal to the 0. At the 30 degrees, the y value of the sine is going to be 1 over 2. Y value of the point is going to be equal to 1 over 2, sorry. So at the 45 degrees, you see, so the y value of this point is going to be equal to the 1 divided to the square root of 2. So at the 60 degrees, the y value of this point here is going to be equal to the square root of 3 over 2. At the 90 degrees, the y value is going to be equal to the 1. So I'm just going to put the 1 here. So you see, so if I'm going through the points on the unit circle, and its coordinates are essentially telling me the values of the sine and cosine. So let's do the same procedure for the cosine. So essentially, I need to go through the x coordinates of this point. So the x coordinate of this point, when the alpha is equal to the 0, is going to be equal to the 1. So the x coordinate of this point is going to be equal to the square root of 3 over 2, right? So essentially, when the angle is equal to the 30 degrees, the cosine of the angle, cosine of the 30 degrees, is going to be equal to the square root of 3 over 2. So now I need to figure out the value of the cosine of the angle at the 45 degrees. So this is going to be equal to the x coordinate of this point, which is square root of 2 over 2, or which can be written as a 1 divided to the square root of 2 as well. So I need to figure out the x coordinate of the point at the angle 60 degrees, right? So this is going to be this point, this coordinate, so this is going to be equal to the 1 over 2, the value of the cosine of the 60 degrees. And whenever I go to the 90 degrees, the x coordinate of this point is going to tell me what is the value of the cosine of the 90 degrees. So which is equal simply to the 0. So you see, so I can figure out the values of the sine and cosine by just going through the points on the unit circle and by just finding their coordinates. So this is how we need to find the values of the trigonometric functions for important angles. Thank you very much for your attention. I hope that this video was helpful for you.